Hello to everyone listening to me. This is A-level mathematics with Ayodeji. Today we are going to be looking at how to form differential equations. Now, this topic is going to be in series. We are starting today. Now, first of all, let us learn about the different orders of differential equations. We have what we call first order. First order differential equation is represented as dy dx. Okay, when you say dy dx, it simply means you are differentiating function y with respect to variable x. Now, second order is represented as the square y over the x squared. When you have the square y over the x squared, it simply means you are differentiating the first order again. That means you are differentiating the function two times. We also have higher orders. We have the third order differential function. The third order is the cube y over the x cubic. So this is the cube y over the x cubic. It simply means we are differentiating again the answer of the second order. That means if you are starting from the function, it means you are differentiating the function three times. Now, today we want to learn how to form a differential equation from a given function. So, I am going to do an example. How do we form differential equation, with a given function? So, example 1. Form a differential equation with y is equal to a cos kx plus a sin kx. Y is equal to a cos kx plus a sin kx. We want to form a differential equation with this function. This is y. Y is a function of variable x. So the first thing we have to do is to find the first order. And the first order is dy dx. That simply means that I'm going to differentiate this function with respect to variable x. Alright, let's start. This is a cos kx. Now, remember that in mathematics, when you differentiate cos, it will give you minus sine. When you differentiate sine, it will give you cos. Now, again, you have to look at the angle of the trigonometry. Here we have kx. So you have to first differentiate what is in front of the cos. If I differentiate kx, it's going to give me k, because k is a constant. So you multiply that k with the coefficient here. So you have a times k. That will be ak. Now, if I differentiate cos, it's going to give me minus sine kx. Then you move to the next one. Differentiate kx. It's going to give me k. You multiply the k with the coefficient. That is ak. Now, if you differentiate sine, you're going to get cos kx. So this is dy dx is equal to minus ak sine kx plus ak cos kx. Now, what I've been able to do is to find the first order of the function. Now, let me go and find the second order. The square y over the x squared. It simply means that I'm going to differentiate this dy dx again now. So let's go. If I differentiate sine, I will get cos. If I differentiate cos, I will get minus sine. So again, you will first differentiate what is in front of the sine. If I differentiate kx, it's going to give me k. So k times ak, you have minus ak squared. Then you now differentiate sine, that will give me cos kx, and plus the same thing here. I will differentiate kx, that is k. K times ak, that is plus ak squared. If I differentiate cos, I will get sine kx. Now, the next thing is to, open the bracket, that is minus ak squared cos kx plus ak squared sine kx. If I differentiate cos, I get minus sine. Minus is supposed to be here, minus sine. So here will be minus ak squared sine kx. Okay, so for us to finish it, let me clean this aspect. Don't forget that the original function is a cos kx plus a sine kx. Now, from here now, I have gotten the square y over the x squared as minus ak squared cos kx minus ak squared sine kx. Okay, so how do I finish up with this? Now I'm going to look for the common factor here and here. I will use that common factor to factorize. So this is going to give me the square y over the x squared is equal to a is common here, a is common here, k squared is common here, k squared is common here. Okay, so it's going to give me k squared Okay, minus is also common. So minus k square into a cos kx plus a sin kx. Now, if you compare this with this, you will discover that what is here is our y. So we are going to replace a cos kx plus a sin kx with y. So this will now give us the square y over the x square is equal to minus k square y. You can bring this to the left. This will become the square y over the x square plus k square y is equal to 0. So this is the final answer of the question. So this is a second order differential equation of this function. I hope you enjoy the class. So this is just the first series. Okay, this is the first class I'm going to be doing on this topic, differential equation. Watch out for the next series. And finally, in case you are a student studying mathematics in Faculty of Science, Faculty of Technology, or Faculty of Engineering in any university, and you are having challenge with this topic, differential equation, you can just go ahead and book with me a free online class trial, and I can assure you that I will guide you to achieve your goal. Thank you for watching, and see you again. I see you again for the next class. Thank you.